Hey, what's happening, guys? I've got something pretty cool for you today. This is a neat little kit. It takes a low voltage and it turns it into a high voltage. For instance, 15,000 volts. So this is a little high voltage transformer kit, and this is from our friends at ICStation.com. And in the spirit of full disclosure, this has been provided at no cost for our consideration. So let's look at what we've got in the kit. Well, first of all, we have the high voltage transformer. We've got two windings over here. A main winding. Oops, be helpful if you could see it, huh? And a feedback winding. The main winding are the thicker wires, and the feedback are the thinner wires. And then on the secondary, this is where we'll have our high voltage spark. Now also, we get a heat sink, the hardware for the heat sink, a couple of transistors with no markings on them whatsoever, couple of diodes, can't really read what they are. Maybe if this shit will focus, you guys can read what they are. A couple of resistors, some heat shrink, and some wires. So first of all, let's take a look at how we can hook all this goodness up and make a high voltage circuit. Bring in the pad and the pen. So I'm not going to do a schematic here. This is going to be more of a block diagram to make it easy for you to understand. So let's start with our transformer. You know, there's our core. And then we've got our main winding and our feedback winding on the one side, and then we have our secondary over here, which will give us our high voltage. Then we also have our transistor, which I believe is probably an NPN transistor, and we have a resistor, and we have the diode. So in order to hook all this up, what we were going to do is we are going to take the end of one of our main windings, and it is going to go to the collector of the transistor. The other one is going to hook up to one end of the feedback winding, and these will go to our VCC. Now the other end of our feedback winding is going to go through the resistor and the diode into the base of the transformer, and then the emitter will go to ground. At least that's the way I plan on hooking it up. Of course, I might screw it all up, and it might go kaboom, which makes for a much more interesting video. Let's take a look at those transistors. Alright, so there's the transistors. Be careful not to try not to touch the pins. No markings on them whatsoever. So let's put this into our component tester and see what kind of information it will yield. And I put a new LCD on here, so it should be nice and bright for us. See if I can spread out these pins a little. Alright, let's see what we got. So it is an NPN transistor, base collector emitter. Okay, we're all set. Can you guys see the screen there? Let me turn off a couple of these lights, maybe that'll help. There you go. Now you can see the screen better and see what we're getting. Alrighty. So the first thing I'm going to do is attach the transistor to the heatsink as soon as I can find a screwdriver. I'll be right back. Alright, I've got the transistor attached to the heatsink, and as you can see, there's really no room to get that nut on there. I mean, I can't even get a single thread, so we'll just have to work with what we got. Alright, next up, I'm going to tin our 3 connections here. And then I'm going to tin the wires that I'm going to solder onto them. Yeah. Okay, so now we will attach the wires to the transistor. First, I'm going to attach this black wire, which is going to go to ground, to the emitter. And this yellow wire to the collector. And the green wire to the base. Alright, I'm going to put some heat shrink on them and I'll be right back. Alright, we've got the heat shrink on the transistor connections. And I also went ahead and soldered and heat shrunk the resistor and the diode together. And if I would have thought even further ahead, I would have done all three of these connections at once, but I didn't think that far ahead. So diode goes into the base of the transistor, just like that. And now we need to turn our attention to the transformer. So we've got our main windings and our feedback windings. And what I'm going to do here is basically just strip off some of the enameling by just running a blob of solder over it, and that will just burn off some of that enamel. That'll allow us to get a good connection. Wipe off my iron, get some more solder. Takes a few seconds to get it hot enough to work. But once it does, you know, you can pretty much see it. Get a little silver there. All right. So now we need to take one end of our feedback winding and connect it to one end of our main winding. I'm going to solder that up nice. Just like that. And then since this goes to VCC, I'm gonna tin this here a little bit, and we will connect these together. And we'll heat shrink. Nice little piece of insulation on there as well. So let me go heat shrink them last couple connections and I'll be back. Alright, next up, our main winding gets connected to the collector, which in this case is the yellow wire. I'm just going to get that to focus. There we go. So I'm going to tin up that main winding there, and also going to tin this And I should be able to just flow them together. I'm laughing because I've got wires everywhere. Alright, let me move this out of the way here. Get out of the way, black wire. Alright. So if we heat that up, flow them together real nice like. Good. And then lastly, the final feedback winding connects to the base, which has our resistor and diode combination. And we should just be able to flow them together real nice. Or not. Ooh. Okay. Now the only bad thing here is I have run out of heat shrink. So let me get some black tape and I'll be back. Alright, everything is connected as far as I can tell. I've used a little bit of electrical tape here to kind of space these close enough to get a spark, I hope. And all that's left is to power it, and to do that we're going to use this DC to DC buck converter, which is also from ICStation.com, and I will put a link to it down below. So we will plug in positive and the negative. I've got it set for 3.7 volts on the output. Let's give her a try. What do you think? Will she chooch or will she bang? Here we go. Nothing so far. Yeah. Maybe these guys need to be a little bit closer. Okay. Power it up. Try again. I saw a little something there. There it is. All right, let me turn out the lights so you can see it better. And here we go. Let's zoom in. There she is. 15,000 volts coursing through there. And not setting my house on fire, I'm happy to say. So I think that's pretty cool. I don't know about you guys, but I think you'll think it's pretty cool too. And if you do, please give me a thumbs up, comment, share. Don't forget to subscribe. Check the link down below where you can get one of these for your very own self. I'm going to go to the web page before I sign off here so we can take a look at it. Hey, okay, here's the page, which I will link in the description down below from ICStation for the DIY kits 15 kilovolt high voltage pulse generator arc ignition coil module suite 3.7 to 4.2 volts, item number 11217. Now, a couple important things to keep in mind with this is the voltage, 3.7 to 4.2 volts. You can push it up a little bit higher, but I wouldn't recommend going above 9 volts, let's say. And then down here in the attention section, it says after you finish the transformers, you need to keep the product under epoxy resin or encapsulation in wax. Basically, you need to pot it, or those windings are going to arc against each other and you're going to have trouble. So we'll do that later on down the line. And again, it says here, cannot increase the voltage over 12 volts. So I will link to this page down below. I will also link to a discount code from ICStation if you want to get one of these for yourself. It's $269 American, and that's a pretty good deal. Well, I hope you guys enjoyed this, and I just want to thank ICStation for their support of our channel. That's it. I'm out of here. Be safe, guys.